Brace yourselves. The sight of it sends some people mad.
That's a black hole.
That's impossible.
Black holes have been capturing the imaginations of humans everywhere for decades.
It's devolving into a black hole!
And yet, very few people seem to understand what they actually are.
Black hole's a dead star. It collapses in on itself, in and in and in, until the mass so dense and tight starts to pull everything else in too. Nothing in the universe can escape it. Light, gravity, time, everything just gets pulled inside and crushed. We should be dead.
Dramatization aside, they're not too far off. A black hole is an object that is so incredibly dense that the gravitational force is too strong for anything to escape from. They form when stars burn up all their fuel. Without nuclear fusion to keep them inflated, for lack of a better word, they collapse under the weight of their own gravity.
With black holes, density is what matters, not size.
Or in other words, how much stuff is compacted into it. Ideally, any mass could form a black hole, so long as it was condensed into a point small enough that it achieved the density necessary.
Scientists use something called the Schwarzschild solution to calculate how small something would have to shrink to become a black hole. For example, the Earth's radius is about 4,000 miles. In order for it to become a black hole, the entire mass of the Earth would have to shrink down into an object with a radius of 9 millimeters. That's a 141 million% decrease.
Black holes aren't hungry monsters that roam the universe eating everything in it. They obey the laws of physics just like everything else. In fact, according to NASA, if we were to replace our sun with a black hole of the same mass, it would have the same amount of gravity, and the planets would continue to orbit around us as normally. Of course, we'd probably all freeze to death, but other than that, we'd be just fine. It's only when you get too close to the black hole that you're in trouble. The closer you are to an object, the stronger the gravitational pull will be. One way to think of this is like swimming against a current. When there's no current, or a low current, you can still move forward. However, as the current increases, it becomes more difficult to swim, until eventually you are being carried in the opposite direction because the current is too strong. On Earth, that means that your feet are being pulled towards the Earth at a slightly faster rate than your head is. You probably aren't going to notice it, of course, unless you're a giant or something. This phenomenon is called tidal forces. With black holes, it leads to something we like to call spaghettification. In this video rendering, we can see a star caught in a black hole's gravitational field ripped apart by extreme tidal forces. If you watch closely, you can see what happens when the part of the star closest to the black hole starts moving faster than the further part. However, if you aren't pulled apart, if you're, say, a photon, it's still possible to escape the gravitational pull until you reach the event horizon, the point where the current of gravity gets too strong to escape. The escape velocity is how fast you need to go to escape gravity. On Earth, that's about 11 kilometers per second, or 25,000 miles per hour. At the event horizon, the escape velocity is the speed of light, and beyond it, nothing, not even light, can move fast enough to escape.